When we gaze at the night sky, one of the most mesmerizing sights is Saturn, a jewel of our solar system. Its magnificent rings, a spectacle of beauty and complexity, have captivated astronomers and stargazers alike for centuries. But what are these rings made of, and how did they form? Hello, and welcome to ZE. Please don't forget to subscribe and hit the bell icon. Join us as we embark on a journey to uncover the secrets of Saturn's rings, one of the most extraordinary features in our cosmic neighborhood. Saturn's rings were first observed in 1610 by the Italian astronomer Galileo Galilei, who described them as ears of the planet, puzzled by their unusual appearance. However, it wasn't until the 1650s that Christian Huygens clarified their nature, proposing that Saturn was encircled by a thin, flat ring. This moment marked a pivotal shift in our understanding of planetary systems. Over the centuries, astronomers have marveled at these icy structures, using increasingly powerful telescopes to study their intricacies. From the early sketches of Galileo to the high-resolution images captured by modern spacecraft, our perception of Saturn has transformed dramatically. Yet, the awe these rings inspire comes not just from their visual allure, but from the scientific mysteries they hold, complexities that challenge our understanding of planetary formation and dynamics. The rings of Saturn are categorized into several distinct sections, each with unique characteristics and features. The A and B rings, the largest and brightest, are separated by the Cassini division, a gap that is not merely empty space but a dynamic region where gravitational forces play a crucial role. This gap, measuring about 4,800 kilometers wide, provides insight into the intricate gravitational ballet taking place among Saturn, its rings, and its moons. The C ring, fainter and less dense, adds to the complexity of this system, while the F, G, and E rings are more tenuous and delicate, composed of smaller particles and intricate structures that defy easy classification. Some regions of the rings are incredibly dense, while others are almost completely devoid of material, illustrating the variety and dynamism of this celestial wonder. Together, these rings form a breathtaking panorama, a celestial tapestry woven from ice and rock that continues to evolve over time. The primary component of Saturn's rings is water ice, which constitutes about 90% of their mass. This ice is not uniform. It varies in size and purity. Larger particles can be as big as a car, while many are just a few micrometers across. This mixture of sizes contributes to the ring's striking appearance. The ice is often interspersed with darker materials, such as silicate rock and carbonaceous compounds, that can give the rings a more muted tone in certain regions. These variations create stunning visual contrasts, brighter regions indicating purer ice and darker areas suggesting contamination from space debris or organic materials. Each particle is not just a simple piece of ice. It represents a historical narrative of our solar system's evolution, revealing the remnants of comets, asteroids, and even moons that have met their fate in the powerful gravitational embrace of Saturn. This intricate mix provides scientists with a valuable window into the past, allowing us to piece together the history of the solar system and the processes that govern celestial bodies. But how did these rings form? The prevailing theories offer intriguing possibilities. One of the most compelling ideas suggests that the rings originated from the disintegration of a moon that ventured too close to Saturn, succumbing to the planet's immense gravitational forces. This catastrophic event would have sent debris spiraling into orbit around Saturn, gradually coalescing into the ring system we observe today. This scenario raises profound questions about the life cycle of celestial bodies and their interactions within a gravitational field. Alternatively, the rings might have formed from leftover material from Saturn's own formation, a remnant of the primordial solar nebula that never coalesced into a moon. This notion emphasizes the interconnectedness of planetary systems and the processes that shape them. The rings, therefore, can be seen as both a graveyard of celestial bodies and a nursery of new possibilities, a testament to the dynamic nature of our solar system. The dynamics of Saturn's moons play a crucial role in shaping the rings. Moons like Mimas, Enceladus, and Tethys exert gravitational forces that help maintain the structure of the rings, preventing them from collapsing into the planet. This gravitational interplay is akin to a cosmic dance, where each moon influences the rings in subtle yet profound ways. As a moon passes by, its gravity can create ripples that propagate through the rings, resulting in intricate patterns and structures. These gravitational interactions not only stabilize the rings, but also lead to the fascinating phenomena we observe, such as waves and gaps within the ring system. For instance, the so-called propeller features are created when a moonlet, hidden within the rings, creates disturbances that ripple outward, causing density waves. Such complex interactions underscore the delicate balance of forces at play in this cosmic environment, painting a picture of a system alive with activity and change. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, provided unprecedented insights into the rings. Equipped with advanced imaging technology and instruments capable of measuring the ring's composition and structure, Cassini captured detailed observations that revealed intricate structures, such as spokes and propeller-like features caused by the gravitational interactions of particles. Its mission allowed scientists to study the rings in ways never before possible. For example, Cassini discovered that some of the particles in the rings are actively changing, driven by the energy of solar radiation and collisions. This dynamic environment suggests that the rings are not merely static features. They are continuously evolving and interacting with their surroundings, much like a living system. The data collected by Cassini has sparked new theories about the rings' age and evolution, indicating they may be much younger than previously thought, possibly forming in the last few 100 million years rather than billions. This revelation has profound implications for our understanding of planetary ring systems and their life cycles. As we continue to study Saturn's rings, we gain not only insights into their formation and composition, but also a deeper understanding of the processes that shape planetary systems. The rings of Saturn remain one of the most captivating mysteries of our solar system, a dazzling display of nature's artistry and scientific intrigue. They challenge our understanding of gravity, material composition, and the dynamic nature of celestial bodies. Each observation leads us closer to answering fundamental questions about the universe. What are the conditions necessary for a ring system to thrive? How do they interact with their parent planets and nearby moons? As we gaze at this planetary wonder, we are left to ponder. What other secrets do the rings of Saturn still hold? And how might they inform our understanding of other celestial bodies in the universe? With every observation, we inch closer to unraveling the intricate tapestry of our solar system and the mysteries that lie within.